In this video, we're going to look at two different questions involving change of momentum. Pause the video now and try question 1. In part I, we're asked for the change of momentum. So what's happening? We've got a ball moving at a speed of 8 meters per second, and then it hits a surface at right angles, and it rebounds off the surface, and kinetic energy is conserved because it's an elastic collision. Calculate the change of momentum. So change of momentum, mv minus mu, is equal to force times time, or we might say this as force is mv minus mu over t. So what's the change in momentum? Well, we actually don't need to even use this, do we? We just need to work out the momentum before and the momentum afterwards. So the change in momentum is obviously going to be the final momentum minus the initial momentum. So it's actually even simpler than this. So the final momentum is going to be to the left. So this is the initial, and the final is going to be this. So we know it's rebounding at the same speed because it's elastic. So we're going to be doing 8 meters per second times by 0.4 kilograms minus 8 times by 0.4, because one of these is positive. So I'm just going to take the final to be positive, and the initial is negative, it's going in the opposite direction. You could do it the other way around, you can make this positive, you'd still get the same answer. It's still going to be twice the momentum. So we've got 8 times by 0.4 times by 2, which is 6.4 kilogram meters per second. What is the force on the ball? So now we want to use this equation, force is rate of change momentum. So force is changing momentum over time. So 6.4 kilogram meters per second over the time, which is 32 newtons. Question 2 is here. Pause the video now and try the question. So in part I, we need to work out the change in momentum. Now it's not quite as simple because we've got a 2-dimensional system rather than a 1-dimensional system. So we need to look at the momentum before and also the momentum after. If we look at it before, we have this situation where we need to work out the x and the y component. This angle here is 40 degrees because this angle here is 50 degrees, which is this angle here between the normal. So we know that the momentum is 3.2 kilogram meters per second. So what is the y component? I'm going to use 50 and you'll see why in a minute, but you could equally do the calculations with 40 degrees. So the y direction is going to be 3.2 sine 50 degrees, and the x direction is going to be 3.2 cos 50 degrees. And then after, what is happening? Well, it's going in this direction here, with this being the 50 degrees. So what's the x component and what's the y component? So the y component is 3.2, because the magnitude of the momentum hasn't changed. So 3.2 sine 50 degrees. So now you can see why I used 50 here, just so it's really obvious that the y momentum has not changed. The x momentum is going to be 3.2 cos 50 degrees, but importantly, it's going in the other direction. It was going in this direction to start with. Now it's going in this direction, so it's negative. So what is our change in momentum? Well, in the y direction, there is no change in momentum. Our only change in momentum is in the x direction. So 3.2 cos 50 degrees minus 3.2 cos 50 degrees, which gives us an overall change in momentum. of 4.1 kilogram meters per second. And then in part II, we want the force on the ball. Well, force is change in momentum over time. This is the change in momentum here. So the force is obviously 4.1 over 0.2, which is 4.1 divided by 0.2, which is 20.5 newtons.